Okay, so good day everyone. This is the example video for free fall and projectile motion. So we have this figure. Okay, so a ball is dropped from a 50 mark of a tall building. It falls freely until it is intercepted by a balcony at the 20-meter mark above the ground. Okay, so the situation is like this. Okay, so the ball was dropped from the 50 mark down to the 20 mark above the ground. Okay. And the person on the balcony picks it up and throws it vertically upward with the speed of 10 meters per second. Okay, so let's see. This is the person, and swiftly it will throw it back up. Okay, so the ball reaches a maximum height before falling to the ground. The figure here is the maximum height for our ball that was thrown from the balcony. Okay, so first question of required velocity of the ball before reaching the balcony. Okay, so let's go first to our first figure before answering the first question. Okay, so ball is dropped. It falls freely until intercepted by a balcony at the 20-meter mark above ground. Okay, so let's go back to our question. Okay, so velocity of the ball before reaching the balcony. This is before reaching the balcony. There is a velocity, excuse me, there's a velocity of the ball falling to the ground before impact. Okay, before impacting the balcony or before touching the balcony. Let's take a look at it again for you to imagine. Okay, can you see there is a velocity, right? Because the ball is acted upon by the force of gravity. Okay, so let's go back to the question. Velocity of the ball before reaching the balcony. Okay, so first, we have your given. Since this is the first special case of free fall, this is our given. V naught is equal to 0, y, or the change in y is equal to 50 minus 20, which is 30 meters, and our g is 9.81 meters per second squared. G here is positive because the particle is moving towards the direction of gravity. Okay, so using the equation v squared is equal to v naught squared plus 2gy, right? Because this is the special case 1, you can simplify this into v is equal to square root of 2gh. Okay, so our solution is v is equal to square root of 2gh, which is equal to 2 times 9.81 times 30, which is equal to square root of 588, approximately equal to 24.3 meters per second. Okay, so that is the velocity of the ball before impacting the balcony. Okay, so let's move on to our next question. The time taken to reach the balcony. Okay, so time taken to reach the balcony. Okay, so let's take a look at our figure again. Okay, so from this point to that point, how long did it take the ball to reach the balcony? Okay, how long did it take the ball to reach the balcony? So let's go. Uh, this is the given. Still, we are in the special case one for free fall. Okay, special case one for free fall. Okay, so using special case one, this is the displacement formula or our y. Y is equal to 1 half gt squared or derive t is equal to square root of 2y over g, which is equal to square root of 60 over 9.81, approximately 2.47 seconds. Okay, so it took approximately 2.47 seconds for the ball to reach the balcony. Let's move to our question 3. What is the maximum height you reach after being thrown upward? So this is our figure now, okay? So this is the figure. How high is this ball from the balcony after being thrown upwards? This is the second case of our free fall. Okay, so we have given here. So in second case, we have v is equal to 0. That means that the ball has reached the maximum height and V naught be equal to 10 meters per second upward. Okay, excuse me, upward. Since this is special case 2, we use this y at h max is equal to v squared, v naught squared over 2g, which is equal to 10 squared over 2 times 9.81, approximately 5.1 meters. Okay, so the maximum height of the ball is approximately 5.1 meters. Okay, so the person on the balcony tried to pick it up and throw it back up without knowing that the velocity is not enough for the ball to reach the top of or its original position. Okay. So next we have your question for time taken. I'm sorry, that's a typo. That's time taken to reach maximum height. Okay. So the time taken to reach this point. Okay. So our formulas are given still here because this is a special case 2, the conditions for special case 2, and this is the time. Okay, so the time up, so T is equal to V O over J, which is 10 over 9.81, approximately 1.02 seconds. Okay, so our final answer for number 4 is 1.02 seconds. It took 1.02 seconds to reach top. But remember, let's go back to I think let's go back to question. Let's go back to question. Okay, so see here. We have the time taken to reach the balcony to be 2.47 seconds. Okay, so using 9.81 as the acceleration for our ball during this moment, it only took 2.47 seconds to reach, to travel 30 meters down. Okay. While it took 1.02 seconds to reach 5.1 meters. Why? Because the velocity here is directed upwards, and upwards is the opposite direction of our gravity. Okay, that's why it took a while for our ball to reach 5.1 meters because with just 10 meters per second as an initial velocity, um, the, the ball did not gain enough force to reach the top, right? So, or to go back to its original position. Okay, so let's move on to our projectile motion example. Okay, so our projectile motion example is this. A motorcycle stunt rider rides off the edge of a cliff. Okay, so this is a cliff and this is our motorcycle rider. Just at the edge, his velocity is horizontal. Okay, so take note, his velocity is horizontal. That means the magnitude for our initial velocity is 9 meters per second, and the magnitude for our initial velocity along x or your v naught x is also 9.0 meters per second. That means we do not have v naught y. Okay, so we do not have v naught y for this case because the motorcycle is not flying or the motorcycle itself is not mm, uh, moving through a ramp or something because the motorcycle stunt rider is riding on the edge of a cliff, and that cliff is purely horizontal. These are the required find the motorcycle's position, distance from the edge of the cliff, velocity at zero point 0.5 seconds after it leaves the edge of the cliff. Okay, let this be our x and y axis or the x and y plane with our starting position at point O, right? Origin. So first for position. Okay. So position, we have this formula. X is equal to V naught X T. Y is equal to V naught Y T minus 1 half G T. Okay. Since we do not have um, V of V naught Y, this means that we currently don't have an initial alpha. Okay, we currently don't have an initial alpha because, but if you take a look at it, we do. That is the initial alpha is 180 degrees, but we're not going to use cosine and sine since we are just dealing with the horizontal component, or we're just dealing with the actual component. Right? So x is equal to v naught x t, which is equal to 9.0 times 0.5 is equal to 4.5 meters. And that is around here. And for our y is equal to v naught t minus 1 half ut, 0 times 0.5 minus 1 half times 9.81 times 0.5 squared. I apologize, I did not put squared for the equation for position at the very first curved rectangle. Okay, so for your notes, just put squared there because in integration, that equation has uh, is a parabolic equation or a quadratic equation. Okay, so for our y, we have negative 1.2 meters. Okay, and that is right around here. Okay, so the motorcycle's position is at 4.5 uh, at the point 4.5 and negative 1.2. Okay, so that is the position. Let's move on to our distance. Okay, so this is the distance that we're talking about. Okay, so let's assume that these two are your vectors. Okay, so let's assume that these are vectors and this is the resultant. Okay, so when we have two vectors and a resultant, two perpendicular vectors and a resultant here, we're going to use the Pythagorean theorem or this, d is equal to square root of x squared plus y squared. Okay, so square root of 4.5 squared plus negative 1.2 squared, we have 4.7 as the distance. Okay, so we have the distance from the edge of the cliff. Okay, so that means that our motorcycle is right here at zero point 0.5 seconds after it leaves the edge of the cliff. Okay, so uh, now we're going to look for the velocity. Okay, so for our velocity, okay, so we have this Vx is equal to V naught x, Vy is equal to V naught y minus gt, and for the magnitude, the velocity, square root of Vx squared plus Vy squared. Okay, so Vx is equal to V naught x, which is equal to 9.0 meters per second. And for Vy, we have 0 minus 9.81 times 0.5, which is equal to negative 4.905 or negative 4.9 meters per second. The magnitude is 10.2 meters per second. Okay, so that is the final answer for the velocity. But since we use Pythagorean theorem, uh, it is not bad to use or to get the direction of our velocity at zero point 0.5 seconds. Okay, so for the direction, we have, as you can see, we have an alpha here. Okay, so that is the direction that we're going to get the angle there. So for our alpha, we have alpha is equal to inverse tan or arctan of Vy over Vx. Solution, uh, arctan negative 4.9 over 9.0, which is equal to negative 29 degrees. This means that our alpha is 29 degrees below the horizontal. Okay, so 10.2 meters per second is at the direction of 39 degrees below the negative x-axis. And that concludes our projectile motion example. Okay, so thank you for listening, class. And um, don't forget to read or to look for other formulas for projectile motion in our book and wait for other lecture videos to be uploaded. Okay, so good day, everyone.